Okay, so now we will talk about the representation of a complex numbers. As you know that we can represent any real number on the line. So similarly, we can represent a complex number on the plane. Okay, so first of all, I will talk about the representation of the real line. Since real numbers can be represented on the real line in this way. For example, if you have a line, and so what will you do? You will represent 0 at the center, and this way you will write 1, 2, up to so on, all positive number on this side, and here -1, -2, up to so on, all negative numbers on this side, all positive on this side, and in the center you have 0. So this way you can represent all real numbers on the real line. Okay, for example, if you want to represent 1.5, you will write here 1.5. This will be the representation of 1.5. So similarly, you can represent any real number on the real line. But if we have to represent a complex number, since complex numbers are written in this form, a plus b iota, where a is also a real number, b is also a real number. So we have two real numbers. So we need two real lines to represent any complex numbers. So these two real lines must be independent. In other words, when we make the graph, we make these two different lines perpendicular so that we can represent everything on each line. Let's look how to make the graph. Suppose this is the graph. In this graph, this horizontal line is used for the real part of the complex number, and this vertical line is used for the complex part of the or imaginary part of the complex number, right? So there are two parts of the complex number. The one is real part and the other one is imaginary part, but both numbers are real. Okay, only we say that this real number is the imaginary part of the complex number and this real number is the real part of the complex number. Okay, so for example, if I ask you to draw 2 minus iota, how can I draw? Okay, so this is the real part 2. So in the center you have 0, here you have 1, here you have 2, up to so on, just like I told you, and here I have -1, here I have -2, up to so on. Okay, and similarly this line is also a real line, but it is perpendicular. So here I have +1, here I have +2, up to so on, and here I have -1, -2, up to so on. Okay, so I have to represent 2, comma, and this number which is -1. So I have to represent this thing. So this 2 along this horizontal line. So here is 2. You can check, this is 2. And I have to represent this -1 along this perpendicular line. So -1 is negative number, so it is down here. This is -1. Okay, so but this is the only one point. I have drawn 2 points, so I need 1 point. How can I draw 1 point? So on each point I will draw perpendicular lines. For example, on this point I will draw one perpendicular line, and on this point I also draw one perpendicular line. They are meeting here, so this is actually the point. So this is the point, okay, in front of both. So this is the point 2 comma minus 1, or 2 minus iota. I will write 2 minus iota. Okay. In this kind of plane, this axis is called real axis, and this axis is called imaginary axis. Because this axis corresponds to the coefficient of the imaginary number, and this axis corresponds to the coefficient of the real number, right? So that's why the horizontal axis is called the real axis and the vertical axis is called imaginary axis. So before drawing any point on the graph, we have to first convert it into an ordered pair, okay? So any complex number can be converted into an ordered pair, okay? So, for example, if a plus b iota is a complex number, then it can be written as an ordered pair, right? An ordered pair, like a comma b. This is an ordered pair. So this is the pair which is ordered. So its first element is real and its second element is imaginary, right? Okay, here are some examples. So convert the following numbers into ordered pairs, right? So I have to convert the following numbers into ordered pairs. So the first one is 3. Okay, how can I convert it? So first of all, I will write 3 plus 0 iota. 3 is equal to 3 plus 0 iota. How can I write it into the ordered pair? Since I told you if I have a plus b iota, then I can convert this a plus b iota into this ordered pair. So first element real and the second element imaginary, right? Here the real number is 3, imaginary number is 0. I will write 3 comma 0. Okay, so next number is 2 iota. How can I convert 2 iota into ordered pairs? Here is the solution. So since 2 iota can be written as 0 plus 2 iota, now it is in the standard form a plus b iota. So what is its ordered pair? It must be first number real and the second one is imaginary part, which is 2. This is an ordered pair. The next example, 3 plus 2 iota. So if I convert this into an ordered pair, so I will write 3 plus 2 iota is the same as ordered pair. The first number is 3 and the second number is 2. So both are given, so nothing to do. So in this way, you can represent any real number into an ordered pair, right? Okay. This ordered pair is sometimes called a point or a vector. Okay. This ordered pair is sometimes called point or vector, which represents this complex number. This vector or this point represents this complex number. Okay, so here is an exercise. So the question is, write point or vector that represents the complex number So here is a complex number, 1 plus 3 iota. Okay, here is the solution. Since 1 plus 3 iota can be written as into this form. The first number is 1, the second number is plus 3. Okay, so this is done. The next part is minus 3 plus 4 iota, and its solution is also again easy. Minus 3 plus 4 iota can be represented as an ordered pair, which is minus 3 comma 4. Okay, so the next one is 3 by 2 plus 5 by 2 iota. Here is the solution. Since 3 by 2 plus 5 by 2 iota can be represented in this way, 3 by 2 here and 5 by 2 here. So these exercises are very easy. Similarly, if I ask you to write this thing, minus square root 3 plus 2 iota, how will you do that? You will write minus square root 3 plus 2 iota in this way, minus square root 3 comma 2. Just next exercise is a little interesting. This exercise says draw the points of the complex numbers. I mean, we will be given a complex numbers. What we will do, we will convert that complex number into a point just like this. Okay, this complex number was given, we first converted it into a point. So what we will do here, so we will be given a complex number, we will convert this into a point. We will go from here to here, and then from this point we will draw onto a complex plane. So we have to do two steps. First I will convert this into a point, and then I will draw. Okay, so here is a point. So it is given that a is a point of minus 3. So minus 3 is a complex number. So first of all, I will convert it into a point, ordered pair. Okay, then I will draw. Since you know minus 3 can be written as minus 3 plus 0 iota, how can I write its point? Minus 3 here and 0 here. Okay, so this is the point. This point is A. Okay, so this is the point. I will draw it on the complex plane. So on the complex plane, this minus 3 decides we have to go along this line, along this horizontal line. Okay, but this is minus 3, so that means we will go to the left of the horizontal line. If it was plus 3, I would have gone to this side, to the positive side. Okay, but since this is negative, I will write 1, 2, 3. So 3 points to the left of the origin. Okay, and this 0 means along y-axis I have to go nowhere. I will not go anywhere along y-axis. Okay, because along y-axis the distance is 0. So that means I have no need to travel along y-axis. So there is no point along y-axis. So since there is no y component, only x component is this one. So this is the graph of this complex number. Okay, let's do the next part. The next part is B is the point of minus 1 by 2 plus 3 by 2 iota. Okay, or you can write it minus 0.5 plus 1.5 iota. Okay, here is the solution. So minus 0.5 plus 1.5 iota can be written as a point form in ordered pair in this way: minus 0.5, 1.5. Okay, now I have to draw it. Okay, how can I draw? Since the things are in points, so I will write this is 0.5, this is 1, this is 1.5, this is 2. Okay, this is 0.5, this is 1, 1.5, this is 2. Similarly, 0.5, 1, 1.5, 2, 0.5, 1, 1.5, 2. Okay, so first of all, this is the first part. The first part is always along the x-axis, along the horizontal axis. Along the horizontal, since this is negative, I will again go back, okay, to the left, 0.5. So this one is 0.5. Okay, okay, now this one is along y-axis, along vertical line, right? Since this is positive, I will go up 1.5. This is 0.5, this is 1, this is 1.5. Okay, so this is 1.5. Okay, now what is my actual point? This point is 1, only 1 point, but we have drawn 2 points. How can I find a point which satisfies this one as well as this one? So on each point I will draw perpendicular lines here, and on this point also perpendicular line. Okay, let's draw this perpendicular line again. So this perpendicular line, these cuts here. Okay, so this cutting point is the actual point. Okay, this cutting point is the actual point. Okay, so this point is the actual point B, minus 0.5 comma 1.5, or you can write this thing as this one, minus 1/2 plus 3/2 iota. So similarly, other points can be drawn on the complex plane.